In this video of Oracle SQL, we will cover the joins. Basically, joins is a very important concept for retrieving the data whenever I want to retrieve the data from multiple tables. As in a database, we split all the logical information in a small entities. So sometimes to get a complete record, to get a complete details of a particular value, we may come across a situation that we should get the data from multiple tables. For example, if I want to retrieve all the employees and along with the employee I want to see that in which particular city they are currently located. So maybe the city location will be there in some other locations table and the employee details will be in some other tables. Similarly, department of a particular employee will be stored in some other table. So for such requirement, we will go for the joins, which will allow us to retrieve the data from multiple tables. But if I want to take a join, there should or there must be at least one common field in both the tables. For example, if I want to check like what is the name of a particular department and along with the department name, I want to get all the employees working in that department. So there should be something common in the employees and departments table. So as we have already seen in our examples, like we have a column called department ID which is there in both, that is the employees as well as in the departments table. So at least one common field must be there in order to make a join, and can be classified on the basis of the data retrieval. There are n number of ways you can perform with the joins. Like some joins will allow you to make the join with the same table, some will allow you to make a join with some other table, maybe the common records or all the records. So on such basis we can classify the joins into this category. These categories are actually on the basis of the Oracle proprietary joins. These are the Oracle proprietary joins with the name like equi-join, non-equi-join, outer joins and self-joins. So basically equi-joins and non-equi-joins are nothing but the inner join. Inner join is something in which only the common data from both the tables will be shown. For example, if I have n number of employees in a table and maybe few employees are there which are not assigned to any particular department. Similarly, maybe we have some departments in our departments table in which there is no employee. So while working with the equi-join or inner join, only the common records, means only those employees will be shown which have a department. So these are the inner joins. If for performing this join you are making the equal operator, means you are using while passing the join condition, if you are using the equals operator, then it is the equi-join. If you are passing any other operator other than equals to, then it will be non-equi-join. But both the joins will give you the common details only. Now next is outer join. While making a join, you will have to specify the type of join, and one table will be on the left hand side, one table name will be on the right hand side while you are writing a query. So basically outer join is not a join, there will be a left outer join or right outer join. So basically what it will do, if we will apply a left outer join, all the details from the left table will be shown and right table will only show the common details. But if I'll talk about the right outer join, so right table will show all the details but left table will show only the matched data. Similarly, next is self-join. Self-join means when a table is joined to itself. When I say when a table is joined to itself, you may get confused, and it is also denying the first line of the slide that it is used to get the data from multiple tables. Yes, for multiple tables we understand, okay, we need to make a join, but if it is a single table we can retrieve the data normally, right? So what's the use of self-join? So basically now I will change this definition a bit and will say like we will use joins whenever I want to get the data from multiple entities, not the table. A single table can have the multiple entities. For example, if you will notice the structure of the current employees table we are working with, it is having a manager ID column. Means I can say it in like each employee has a manager, and when I say manager, each manager has a worker who is working under him. So basically the single entity employees can be split now into two entities, that is a manager and the worker working under this manager. So in such scenarios you can go for the self join. So let us see all these kind of joins practically. So for retrieving the data from multiple tables, here I have the structure of two different tables. The first one is departments table, where we have the department ID, department name, manager of that department, and the location ID. While here in the employees table we have the employee ID along following with some employee details and again a department ID. So whenever you will get the data from multiple tables, there should be at least one common field, as I already shared with you. And here the department ID is that field. Make sure that the name doesn't matter, but the data that is inside those tables, that actually matters. So even if the column name is different, it will be fine enough and you can continue with your joins. So for making the joins, I'll do the very similar thing as we have done earlier. Like here also what I'll do, I'll get the employee ID followed by the employee first name and the department name. So for doing that, what I'll do is select employee ID, that's the first column I wanted to get, then the first name of the employee, and after that the department name. Department name is in the departments table. So department underscore name, that's the name of the field. So if you will write this, obviously for these two fields, the first two fields, you will have to make a request with the employees table, while for the last you will have to get it from the departments table. So here in the from list, what I'll do, I'll say from employees comma departments. Alright, so here you will get the data from both the tables. Now if you will execute this command right here, you will get a Cartesian product. Cartesian product is basically the product of both the tables. That means each employee from the employees table will be joined from each department from the departments table, which is obviously not a correct idea. So whenever you will make a join, you will have to pass the join condition. So here what I'll do is I will simply say from departments where employees dot department ID is equal to departments dot department ID. Since the name of the column is same, so to get rid of the ambiguity, I'll have to mention the table name in the prefix. If the column names are different, you can continue with the normal comparison without putting the table name in the alias, in the prefix. So let's execute it now. And here you can see there are 106 records. Actually there are 107 records in my employees table, out of which one employee is not having any department, that is employee ID 178. Alright, so you will not get that particular record, otherwise all the records are here itself. Now you can see like each employee is working in a department. The condition which I mentioned here is clearly telling you like the join should be there when the department's ID are getting matched. So here only the common fields are getting there in the output, and I am using the equal operator for the join. So you can call it an inner join or the equi-join. If you will use any other operator right here like greater than, less than, then that will be non-equi-join, but the overall impact is going to be same, like the only common records will be there in the output. I can also use the table prefix in the column name like e.employee name. Here I am just aliasing the table also, which I'll do later. e.employee ID, e.first name, d.department name from employees, and right here you can put the alias like employees E, departments D. And rather than putting the where clause like this, you can just put the table alias like e.department ID is equal to d.department ID. Alright, the reason why I'm putting these column names with the table prefix, just because if you are making the join from more than 2 tables or maybe 5 10 tables, you may get confused, like, okay, if you are finding a particular record of a particular column, from which table this column is coming. So if you'll put a table name in the prefix, the syntax will be even more clear. So if I'll execute this one, the output will remain exactly same, but the way of writing the statement, the query, is a bit different. Now, if I want, like, the department from from one of the table, I want all the records should be there. For example, right now I want all the records from employees table should be there, and all the common records from some other table. So in that case, I need to go for the outer join, and outer join can be divided into two parts here, called left outer join and right outer join. Like here, in this particular syntax, you can see e.department ID is on the left hand side of the equal operator and d.department ID is on the right hand side. So for me, E, that means employees, is the left table, while D, that is departments, is the right table. And here, if I'll put the plus symbol like this in the parenthesis on the right hand side, I will always put the plus symbol on the deficient side, means the table which is showing me lesser records. If I'm putting the plus symbol on the right hand side, that means it is a left outer join and it will show all the details from employees table. So when I will execute this, you can see there is someone called 178 Kimberly who is not in any department. Alright, so this is because I use the plus symbol on the right hand side, that is the left outer join. That's why it shows the all the records from the employees table. But if I will put this plus symbol on the left hand side, then it will be a right outer join, and now it will show all the records from the right table, means these are all the departments in which you will not find any employee. So this is how you can work with the left and right outer join and the equi join. After that, let's have a look with the self join as well. Let me clear the screen first, and here let's see the structure of my employees table again, where I'm going to put the self join. Like here, employee ID is there in the employees table, and along with that there is something called manager ID. If I'll talk about the manager will obviously be the person who is working in a company. Like, manager is also an employee, means all the managers are an employee, but all the employees are not managers. Some of those employees are manager as well, and someone are the workers. So I can split this single entity called employees in a multiple way. Like, I can split this employees table as the manager and as employees table and as a worker table. One will be manager, one will be worker. So let's see how can we do that. So logically we will split the overall scenario in the two parts from the very beginning. So what I want is, I want to get something like, in first column I want the manager name, in second column I want the worker name. So what I'll do is m dot first name comma w dot, and let's put the alias as well. M dot first name means he's the manager, that's why it's M in the prefix, and W dot first name, that means it is the worker. Let's put as well. Alright, from, obviously it's a single table, employees, but I will use this particular thing in the two different ways. For example, the employees M comma employees W. Alright, so what it will do, employees M dot first name, W dot first name, because obviously I'm getting the data from the employees table only, but I'll have to use this single column in the two different ways. So that's why I use these two different aliases for the same table. Now the main thing will come in the condition, because if I'll say Mr. A is the manager of Mr. B, that means the manager ID for employee B will be equal to the employee ID of manager A. Alright, means if B is a worker of manager, or I should say A is the manager of B, alright, A is the manager of B, then obviously for employee B, the manager ID of B will be equal to the employee ID of A, because A is the manager and as well as an employee. So here what I'll do is I will write E dot or W dot manager ID is equal to, that's the manager ID of a worker is equal to the employee ID of a manager. Alright, so that's as simple. And here you can see all the managers and workers are coming together. Like Stephen is the manager of Nina, Stephen is the manager of Lex, Lex is the manager of Alexander, Alexander is the manager of all these members. Alright, similarly Nancy is the manager of all these members. So this is how you can actually make the self join, where you will only use a single table for putting the join, and you will split a single table as the multiple entities. Now it is SQL Compliant Joins. We have already seen some type of joins already, like which are the operator proprietary joins. Now it's turned to the SQL Compliant Joins, and here we will cover the cross join, natural join, join through using clause, and full outer join. So basically cross join is nothing but a Cartesian product, means when you omit the condition which you want to specify while making a join, it will be a Cartesian product. And similarly in this particular type of syntax you can call it cross join also. Next is natural join. Basically in natural join you don't have to specify the common field name. In both the tables, whichever field will be having a common name, this natural join will automatically take that field. But if in case there are more than one field are there which are having a common name, like maybe for a particular employee, the department ID will be there and a manager ID for that employee will be there. In departments table, department ID is for each department will be there, and the manager of each department, maybe manager ID, is also there. So if you will go for the natural join between the employees and departments table, so it will consider both the columns for the join. But if you don't want to go for both the columns, you can use using clause, and inside the using clause you can just pass the name of the column which you want to make as a common field between the two tables. And the last is full outer join, which will be a combination of left and right outer join. Basically this full outer join will give you the full details, means all the records from both the tables, that is from the left as well as from the right. So let's go quickly and see how can we use these joins practically. So now let's begin with the cross join, and here to make a cross join I will use the cross join as the keyword. So here what I'll do is, first of all I'll select some fields from the first table, that is employees, and some from the second table, that is departments. Let's say department underscore name from employees. Alright, and after using the cross join keyword I will write the name of the second table, means here I'll have to spell out the name of the join in this particular syntax. So what I'll do, cross join departments. So basically cross join, as I said, is equivalent to the Cartesian product, so you don't need to specify any condition while making this join. And here as you can see, like the Cartesian product, the number of rows are equal to the number of rows in the table 1 multiplied by number of rows in the table 2. Now but obviously it is not a very good idea to write such kind of join, so I'll it's just about the syntax. Now let's go through some more important joins, and now I'll go through the natural join. So for natural join, as I said earlier, it will automatically take the fields from the two tables which have the same name. So I'm not going to join this time with the respect to the employees table and the departments table. Departments, all right. because here you can see department ID and the manager ID are the two fields which have the same name. So the output will not be that much clear. That's why I'm not taking these two tables in this, but rather I'll take locations table. So in the departments and in locations table, you can see the location ID is the common field. So by the time I'll be making a join, I don't have to mention the specific common field name as we used to do earlier in the previous joins. So what I'll do here, I'll simply write a join query. So for that, let's say department name, comma, city which is in locations table, from departments natural join location. So as I said, it will automatically take the common field from the two tables having the same name. So you can see all the records are here, means most admin, marketing, purchasing, all the departments are here, and with the different cities like Seattle, Toronto, London, San Francisco, and so on. Alright, so this is how you can go through the natural join. If there are more than one field which have the same name, natural join will consider that as well in the condition. But if you don't want to go for the multiple tables join, for example, I was talking about the employees and the departments table. So here if I'll make a join with these two tables, like first name, comma, department name from employees, natural join departments. Alright, so you can see only 32 records are here, because obviously it will be comparing both the fields, that is manager ID as well as the department's ID. So rather than finding the things in this way, if I want to go for only one particular field, I can do that as well by using the using clause. And at that particular time, what I'll do is, alright, like these are the two fields, from employees. Now I'll not specify any particular join type, alright, like natural join or cross join. I'll simply write join, which will be equivalent to the inner join, and departments, and after that using the field which you want to specify, like department ID, which is the common field. Though there are two fields out there, but here I am specifying the field name. Again, this column name must be same in both the tables. If the field name is different, you will not be able to go for the using clause. So here now you can see I got all these employees with their department names, alright, except those who don't have any department, because as I said, it is equivalent to the inner join. It will only take the common data. Now finally, if you have the different names in both the fields, such as, I'll continue with the same example, but maybe there is a situation like you don't have a common name in both the tables of this common column. So at that particular time, you can go for the on clause. So on employees dot field name is equal to departments dot field name, that is again department ID. In this case, though I have the same name, but if you have a different name, you can simply specify that to get the same result. Alright, so here I just specified with the on clause in the case both the tables has the different field name. So here you have different varieties, like if you have only one field in common and you want to take that, you can go for the natural join. You don't have to specify any common field. If you have multiple common fields and want to specify only single, you can go for using clause, but the condition is both field names would be common, should be same in both the tables. And finally, we have this on clause in case we have the different names. So this is how you can specify the joins in a different ways. Now let's have one more example where we will see like how can we make a join using more than two tables. For example, what I want is I want to get the first name of the employee, the department in which he is working, and the city where he is located. Alright, so this first field is in the employees table, second field is in the departments table, while the third field is in the locations table. So what I'll do, from employees After that, I'll use a join keyword and then the second table name, that is departments. Now here I'll go for on employees. You can give the alias of the tables as well to get rid of the full names, writing the full names again and again. Department ID is equal to departments dot department ID. Again, you have to specify join, then the third table name, locations. So what it will be doing, it will be joining the second table with the third table. All right, means departments will be joined with this locations on departments dot location ID is equal to locations dot location ID. Alright, similarly, if you want to go further, you can again use the join keyword, then the table name, and then after using on, you will specify the condition. So here you can see all the 106 employees are here along with the city and the department name. So this is how you can go for the multiple tables join. Now finally, let's have a look on the outer join. So for specifying the outer join, I'm going to use only two tables now. So let's go for this one. From employees, now we have already discussed about the left outer join, right outer join, and so here the implementation will be as similar, but the syntax is different. So here I'll have to write the left outer join, table 1, that is the first table is left table, second table is the right table. When I say left outer join, that means all the record from the employees table will be there, department ID. Alright, so here you can also go for the on clause, but here I'm using clause. Alright, so both are same. So here as you can see, Kimberly having no department is here in this output. Similarly, I will change this left to the right and it will be a right outer join. Means syntactically it is more clear than the previous options which we have covered. And here in the right outer join we will be getting all the department names right here. Similarly, there is one more option right here in this particular syntax where we can get the data from both the tables, that is the full outer join. It will be simply a combination of the left and right outer join. So here you will get all those departments having no employees along with that employee having no department. Alright, so this is how you can start implementing the joins in the Oracle.